All right, let's do some reciprocal functions. These you won't have to sketch quite as often, but it's good to know the shapes. So these are just screenshots out of Desmos. I went ahead and started with a graph of cosecant. These are called reciprocal functions because reciprocals are just fractions, flipped over. So if you start looking at this cosecant formula, cosecant is 1 over sine. So cosecant and sine are paired together. We can use the same technique we used when we were graphing tangent by looking for zeros. So zeros are values that would cause the numerator to equal 0. It's a u. So I look at the numerator for cosecant. Cosecant is 1 over sine, so all I have to do is figure out when 1 is equal to 0. Well, that's never going to happen, which means this graph never crosses the x-axis. So if you start looking at the graph over here, you can see here's our x-axis, no x-intercepts. This graph never crosses the x-axis. That's a technique that you want to keep in mind. Numerator can't ever be 0. The graph can never cross the x-axis. So we look for vertical asymptotes, and you can see this one actually does have vertical asymptotes, quite a few of them here. So vertical asymptotes, you remember, are created when there's a value that causes division by 0. So we're going to look for the values that would make our denominator in this function 0. In that case, our denominator is sine x, so we're going to take sine x, set it equal to 0. And this is where knowing your unit circle pays off again. I'm looking at my unit circle. Oops. I'm looking at my unit circle. Here it is. I know my sine coordinate is my y coordinate in these, so I'm looking for a y coordinate of 0, which happens right here. And over here on my pi mark. So I've got 0 and pi should be locations of vertical asymptotes. So if we go back up to the graph, here's pi. Desmos doesn't draw these in, but I'm going to sketch it in here. So see, vertical asymptote at pi, vertical asymptote at 0, another vertical asymptote over here at 2 pi, and that just comes, if you're using your unit circle, that just comes from going from the pi over here to 0, which is also 2 pi. So we can just keep going around and around and around until we have 2 pi, 3 pi, 4 pi, and then we can go backwards. We can have this vertical asymptote, you see it right here, at negative pi also. Oops. So now let's look at the next one. Cosecant is our fifth of our 6 trig functions we need to know. There's only 6. Secant, did I say cosecant? Secant is 1 over cosine. So if we start looking for the zeros of this graph, we take the numerator, set it equal to 0. Our numerator is 1. 1 is never going to equal 0, so this is never going to cross the x-axis. And you can see that if you look at the x-axis here, this graph never ever crosses. Vertical asymptotes, continuing with our techniques, vertical asymptotes occur where we have division by 0. So on this problem, we're dividing by cosine x. So any value, any x value that would make that cosine equal 0 is going to cause a vertical asymptote. So again, I sketch, quick little sketch of a unit circle. This is what's going on in my head. I know cosine is the x coordinate of the coordinates on here. So I'm looking for a 0 x coordinate and whatever else the y coordinate would be. Well, 0 x coordinate means don't go over any. So that would be up here on top and down here on the bottom. Well, the radian measures on the top is pi over 2. Radian measured down on the bottom is 2 and 3 pi over. That's 3 pi over 2. So you can see if we go back up here, notice this x-axis goes 0, pi, 2 pi. Pi over 2 is right exactly halfway between 0 and pi. So there's our vertical asymptote. 3 pi over 2 is 1.5 pi. So that's halfway between pi and 2 pi. So there's my vertical asymptote at 3 pi over 2. Same thing if I go left, halfway between 0 and negative pi over 2. Got my vertical asymptotes going in there. And those will just keep going and going. Notice the length of this, the distance between these vertical asymptotes is pi, so our period on cotangent? Nope, on secant is pi. Okay. Now I sketched over here on the left side. I did a quick sketch of cosine because secant is the reciprocal function that goes with cosine. And when you go to try to sketch this secant graph, you can see these little, I call them UEDOs, that's not a math term, but these little UEDOs have vertical asymptotes. And the only difference between our secant graph and our cosecant graph, it's the same shape, little UEDOs here, same shape, but the location of the vertical asymptotes is different. So that's going to change, and the vertical asymptotes are just located where we have division by zero. Well, if I know cosecant is the reciprocal function with sine, so I'm going to be looking for where sine is zero. If I can remember my sketch of sine, instead of using my unit circle, I can go to where the sine graph crosses the x-axis, and those will be the locations of my vertical asymptotes. Now, if you really want, let me pick a different color here. You could, if you want to visualize it this way, you could, I'm going to sketch this dashed because it's a guide to help us see this. If I sketched a sine wave, you can see that at these points, let's make them, these points right here where the sine wave crosses the x-axis, that's where the vertical asymptotes lie. So another way to sketch this function is to do a quick sketch of your sine wave, find where the sine wave crosses the x-axis, and those are your vertical asymptotes. Now while we're here, the other thing that becomes important on these sketches is how high, or what's this y-coordinate right here in the bottoms of these UEDOs and these upside down UEDOs, my word, not a math word. What's that y-coordinate of a high point? Well, it turns out you get that off the amplitude of your sine wave. If my sine wave has an amplitude of 1, I know the coordinates of that point right here are, what's it going to be? Pi over 2, y-coordinate's going to be 1. The y-coordinate at this point down here is going to be negative 1 because my amplitude of my sine wave is 1, so it goes down to negative 1. That works on our secant graph too. Cosine and secant are reciprocal functions. So any place cosine is 0, that's where these vertical asymptotes come from. So if I do a sketch of cosine on here, cosine, remember, starts at 1, crosses the x-axis, drops down, comes back up to 1, and I can continue that pattern. You can see, oops, that wasn't a very good sketch, was it? There's a point where the cosine wave crosses the x-axis. There's a point. Those are my zeros. And the places where, oops, should have been over here a little bit more, shouldn't it? The places where my cosine value is 0 causes division by 0, so that's how I locate my vertical asymptotes. I know I'm hitting this hard, but it's something that I need you to know in the future. So division by 0 causes vertical asymptotes. You can use either your unit circle to find those locations. If you like unit circle, if you prefer sketches, you just got to do something that helps you remember where those vertical asymptotes are. So if we continue on to our cotangent, cotangent is a reciprocal function with tangent. If we apply a little bit of algebra to this 1 over tangent formula, I know tangent is sine over cosine. I know 1 divided by a fraction. I'm going to keep that top. I keep my 1 right here. I flip this fraction over, multiply by the reciprocal. There's that word again. And I've got cotangent is cosine over sine. These are the two forms you're going to want to remember this formula, depending on what we're doing. Sometimes the 1 over tangent's nice, sometimes cosine over sine. In this case, let's just go with the, we're going to actually use both of them a little bit. Tangent. Remember the tangent graph? We just did a video on that. Is this shape. It's got the vertical asymptotes. Well, cotangent is the same general shape, except it's instead of starting low and working its way up to the top as you move to the right, it's going to start up high and drop down as you work to the right. Then you need to be able to locate, let's go a different color, locate the zeros. If I'm going to find my zeros are located at the value that causes division by 0. In cotangent, sine is on the bottom, so I'm going to look for where sine is 0. Sine is 0. I like my unit circle, so I'm going to do a quick unit circle. Sine is my y-coordinate, so sine is 0 at 0, pi, 2 pi. So, oh, that was silly. These are not zeros. These are vertical asymptotes. My bad. I'm sorry, you guys. Did you catch that before I did? I hope so. Vertical asymptotes. So I have vertical asymptotes right here. Let's go a different color so they show up. Purple's pretty. I have vertical asymptotes at 0, vertical asymptote at pi, vertical asymptote at 2 pi, and go this one back here. Then the zeros, silly me, the zeros occur where the top of the fraction is 0. So I'm going to look for where cosine is 0. So unit circle, cosine is the x-coordinate. The x-coordinate is 0 way up top here and down on the bottom. So I've got pi over 2, 3 pi over 2, and you can see that. Here's pi over 2 is my first place where this graph crosses the x-axis, 3 pi over 2, and I can keep going. This would be negative pi over 2. So you can locate your zeros and your vertical asymptotes by using your knowledge of trigonometry, cotangent. I think it's easiest to use this cotangent formula. Zeros come from the top of the fraction being 0. Asymptotes, vertical asymptotes come from the bottom being 0. All right, that's it for the reciprocal function.